I want to talk about the two formulas that we've seen so far for the slope of the tangent line, and just why there are two and what's the relationship between the two. They're really very, very similar. You shouldn't think of them as two totally different ways of doing things. The main difference is the algebra turns out to feel a little different in the different ways. But there's also an important, if you feel like you don't understand why they would be the same formula, it's a good indication that you're not understanding the concept. So let's go through it here. So here we have a curve, y equals f of x is a graph. And here's a fixed point A. So for now, A is going to be fixed. And very soon, we're going to try to do this for all possible A's and get all possible slopes of tangent lines. But for this discussion, let's talk about A being fixed. It's from the beginning of the alphabet. That's to suggest that it's just a number. And most of the time in the example so far, it has just been a number. We did one example so far where we let it be a letter, and that's a little more complicated. But let's just think of it as a number. And what am I doing? The process, as always, is to look at a bunch of different points. And it's really important that we look at all these different points nearby to the fixed point A, that's the x value A, nearby this point on the curve. And we look at all these secant lines and calculate their slopes, rise over run. And so here's the rise, here's the run. I guess I didn't label the rise yet, but I will in a minute. And look at what happens when these 2 points get very, very close to each other. And it's the difference between the two formulas is basically there's just two different ways of saying when two things get close to each other. So we got a fixed A, a variable x, and one formula is this one. It happens to be the one that they do first in the book. It's putting x and A kind of on somewhat equal footing, but it's important to realize that they're very, very different here because A is something we're thinking of as an actual number. That's a real honest-to-God location of a specific point. And x is what's called a dummy variable. It is temporary, and it varies as we do the process, and then we throw it away as we go, because we're really interested in the trend as those x's get very close to A. So when these 2 points get close to each other, that's saying that x, the variable point, gets close to A, the constant point. And we look at the differences between the heights, that's f of x, that's f of A. Look at the difference between those heights. That's the height of the sky, it's the rise, over the run, which is x minus A. And so that's going to be rise over run. We take the limit, and that's going to be the slope of the tangent line. The other point of view is that we concentrate not so much on x and A, the two numbers, but the difference between them. And to some extent, that's really a better way to do it, because that's really what's interesting. What's interesting is not that x and A are some random numbers, it's they're close to each other. And a simpler way to do that is to define h to be the difference between them. And then what's that going to do? As x goes to A, then h is going to go to 0. And that's a little bit simpler in some ways. But then how do I rewrite this guy? Well, the bottom, x minus A, we've just decided to call that h. It's simpler. The f of A is still the same. This height is still f of A. This is still a fixed point. But now what is x? Okay, x is going to be h plus A. So the relationship algebraically is very simple. It's that h was defined to be x minus A, and then if I want to privilege A and h and not x so much, the variable point, but if I do need to recover x, it's just A plus h. You start at A, like this is 1, and then I want to think of x as like these 0.001s that we were doing when we were doing this in tabular method. This is going to be the 1, and then you add the 0.001 to get 1.001. And that's really the relationship between the two. So it's a little bit of a different perspective. But the main thing, main reason is just that the algebra works out differently. Even you're going to get the same number in the two definitions. And we've seen examples of how maybe one would be a factoring formula would be crucial, one would be a binomial or something like that. And sometimes one is a little simpler than the other to do it. It's good to have control over both. But mainly the idea is we've got this fixed A and these variables, either x or h, doesn't really matter how you do it, that investigate what happens when these 2 points get really close to each other. Okay.